using it.
Okay.
And once we get past that point and get into this inverter, this is 9,000 volt high voltage module, which would be, it's a version of a Tesla coil, except it's a solid state version.
Okay, that makes sense.
It does the same thing as a Tesla coil, except it's solid state version of the same action.
Yeah.
So anyhow, in order to control that, since we don't want to use the full 9,000 volts, I have a neon tube transformer control here, which controls the amount of the 110 volts that comes out of this into this.
Okay.
I can use the whole 9,000 volts, or I can use any part of it. And the reason I have to cut it back is because what's over here cannot take what's over here. Well, I'm going to end up with a lot more voltage than I can manage.
Well,
so I have to reduce it. It's easier to reduce it on the low end. Once it gets to the high end, you have trouble, special equipment, and a lot of trouble varying it.
Okay.
So I vary it on the input on the low side.
Yeah.
Okay, I get to the high voltage module, and on neon tube transformers they have two output wires. So I have to take the electricity that's on the two output wires and put it back together as one source of electricity. And then I have to pump it through the L1 coil and then back into the system. And then I have the capacitor bank here in order to help regulate that.
And that's, I'm sorry, you said that was 100,000?
No, these are 10,000.
Okay.
Or maybe 15, I don't recall just at the moment, but they're more likely 15.
Okay.
But they were done special order by Cornell Dubier for me, and they were free.
Well, that's nice.
Because most of the companies like that have a department where they will make up samples for you if you're doing research and development, and you need something which they don't have in the catalog. They will make them up special for you, and that's exactly what happened here.
Really?
Okay, once we get to the this is the broadcast end of it, or the part that sets the electromagnetic field into oscillation.
Now, how do you do that? Is it sending a radio wave through?
Well, it's when you pulse something and you pulse it through a coil like this, a magnetic field builds and collapses.
And that's all you.
And it's a collapsing, building and collapsing off and on that spins the electrons. The magnetic field and then the magnetic field off, and they'll spin back to where they were. So you've got the coin flipping with the electromagnetic component flipping. And once you've got it flipping, then you're in business.
So that's the whole trick to this. Is just
yeah. Once you've got it flipping, then you've got to have something to collect it with. And then the rest of this is the collector and storage part.
So what do you have, just a couple of capacitors there? And
no, those are, actually there's 8,000 volts worth of capacitors there.
Are those special made?
No.
Really? What's the little tube on the end there?
Which one?
I'm sorry, the little yellow...
the yellow one?
Yeah.
Okay. That has a double meaning. In this case, it has no meaning because I've already charging the battery from over here.
Oh, was that used to...
But the energy coming from here before it goes out to the transformer is passing through this one, and that's building a magnetic field. This one is not connected to this one in any way except through a magnetic field. So this becomes a generator of electricity, and you can charge batteries from that. That's
great. That's a great system. How much energy would you say this little system could produce?
This one? What's the output on it?
Yeah.
It's about 16 kVA.
Great.
Which is a lot of energy.
Yeah. And
it could go higher than that. That's with this thing turned down on low.
Wow. Now, does it, like, run itself out?
No, there's nothing here to wear out.
Wow. So there's no...
the capacitors are self-healing,
So this is it. You've got a closed loop system that charges itself and kicks off enough energy to.
You know, once it's going, it's on its own. No, this is sort of an intermediate model.
Yeah.
And there's a larger one sitting over here, a more commercial type. This one actually, the one in the suitcase calculates out at about, I put in the book a little article I gave you, I think it was 27 kVA.
No kidding.
It's it's about half the size of this.
Wow.
So this is capable of probably around 50 kVA.
Now, is this something that you give away as far as selling plans to people or showing people how?
Well, the plans for some of these things are in the publications.
So this is not any great secret. This is out there.
No, it's looking people in the face. A commercial model, and the absolute output level on it, I don't know, but some of the components in there would probably limit it to about 35,000 volts at probably about 200 amperes. And that is an enormous amount of electricity. So you can see that it has the same components that the other device has. They're just scaled up somewhat.
Have you used this one here?
I've had it. I've started it, and I know that I've tested it, but I haven't ran this particular one for any extended period of time, except to just start it.
So this was just sort of an experiment to see if you could build a commercial.
Well, basically, it was just to see how the components fit on the board. Was what it was.
Great.
Because I did the schematics and passed them on to other people, and they're building them.
Okay. Great. Use that on this device.
Actually, I'm going to show you how to make a simple one.
Okay, great.
Most of the things that are in my devices which I demonstrate were put there because people expect to see them, not because they need to be there.
Okay.
Okay, so this device, which I had turned upside down. Okay.
Great.
Is the high voltage module here. So we come out and we need a L1 coil here. That's going to be our L1 or input coil, and we're going to run this. Since this is alternating current, it's neither plus or minus. It's going to be what it's going to be doing is coming over here and into here and coming back just like that.
Okay.
So we've got our high voltage device and we've got an L1 coil, and it's all working just fine. At this point it's running at 35,000 cycles per second. Okay, and we don't, the method I'm teaching you here, you don't have to know about tuning. The fact that the length of the wires that go on this coil here are basically irrelevant because it's being pumped by the high voltage device here, and that's going to set the frequency. The length of the wires are not going to have anything to do with it. So you don't have to know how to tune it to do this. Okay, the next thing is that we're going to have an L2 coil here, and it's going to have coils on it, and it's going to be out, and this is going to be your minus, and this is going to be your plus down here at the bottom. And electricity or electrical field always moves from the highest of concentration to the lowest. But in this case, what's happening is each coil there has a capacitance and inductive characteristic. So